Okay, Aubrey and Michael, we are on example 6, and we've just got a little bit left to do. So here we go. Homework for this section. Do you guys have this all written down?
Yeah.
Here's homework.
Hey, what was the aunt's name?
Tracy.
Bonnie.
Aunt Bonnie.
Bonnie,
Tracy, and Donna.
Oh, I know. Those are all made up names. I don't know who they are, but anyway. Okay. All right, example 6. Here we go. Express as a single log. We did one of these yesterday, and now we got to do a few more. So B and C. Ready, set, go. We have 3 logs that we're trying to put together. 1, 2, 3. And minus between these. That's going to mean we're going to divide those. Okay, but first and foremost. Yeah. First and foremost, we've got to move these numbers to the back. Right? The 1/2 gets moved to the back. The 1/2 gets moved to the back. So this is now a to the 3rd power, yeah? Okay? This is b to the 1/2 power. What's the 1/2 power mean? The square root. So I'm going to write it, instead of 1/2 power, I'm going to write it as the square root of b. And c is also to the 1/2 power, so this is the square root of c. So I'm going to get rid of my 1/2s, my 1/2, and my 3. Okay? Now, log of a to the 3rd. They're all going to go underneath of one log. So I'm going to just do log, and I'm going to do a big fat parenthesis, and we're going to put all the other stuff in there, okay? A cubed goes on the top because he's positive, but the minus is for both of the other ones. So those are both going to go on the bottom. How are you going to put them together?
Put them both under the same root.
Yeah, let's put them all underneath of the same square root, so BC, like that. Yeah. Since they're both square roots, we can do it like that. Got it? Got it, got it?
Got it.
Okay.
China.
Anything else that we can do for that?
She's on a video. This is funny. They're not gonna.
I know they're not going to know what we're talking about. Anywho, it's fine. It's fine.
Oh.
Okay, ready? Next.
Okay.
Okay.
Does that to me, I'm doing the opposite thing they say. Oh, I'm not gonna listen to that.
Will you put your chair up?
Okay. Gentle parenting does not work for Carter. Okay. 1/2 gets moved to the back. That means this is the square root of x, yeah? Anything else we need to move to the back?
No.
Okay, so ln is our overall operation. I'm going to do a big fat parentheses. What do we got going on here?
Square root of x.
The square root of x
Times x squared minus 1.
times x squared minus 1, like that.
But
Over.
don't they go away? Don't the x?
No, because it's trapped, isn't it?
Yeah.
Oh, maybe not. No.
What go away?
The square root of x and
No.
x squared.
No,
Yeah, I can if we put them together.
No.
It would be
No.
X
If you're putting these together, this is x to the 1/2 power times x squared. You add the exponents. You're not multiplying them, right? If it was like the square root of x, that thing squared, then they would cancel. Or x squared square root.
Got it.
Then they would cancel. But when they're like that, they can't cancel. Now, there is one fancy thing that can happen. Did you guys see this?
She says that too.
Got it?
Oh, we can split that guy up.
This guy is a difference of squares. Okay, so
Pretty sure.
x squared minus 1. The square root of x squared is x. The square root of 1 is 1. So one of them's plus and one of them's minus. And then what?
Now this is what the bottom goes away.
Now the x plus 1s can cancel. Okay, so I've got ln, parentheses. I have no bottom now. But what do I have left?
Square root of x.
Okay. Times x minus 1. Do you see how everything canceled? Like the other part canceled? Difference of squares, we broke him apart, and then we can cancel him with the bottom. So there he is. He's simplified. Don't distribute your square root through. We'll just leave him like that. Otherwise, it's going to make him uglier than he was before. Okay? Good? All right. Let's see. Example 7. Ready. This one's going to be the hard one. You have one like this, I think, on your homework assignment. And these ones are kind of weird because, like, people just lose their minds. It's not supposed to be that hard, okay? We know they are telling us what log base b of 2 is. They give me the decimal. And what log base b of 3 is. So what we want to do is we want to find the value of log base b of 36. And we want it in terms of 2 and 3, right? Okay, so I want to break, basically, 36 down into numbers that are 2 and 3, right? You see how this works? Okay? So if I do like 36, let's say, I don't know, 36 is 2 times 2 times 3 times 3. Check that. 4 times 9 is 36. Is that what it is, right? If I break it down in terms of 2 and 3s, right? 36 is 2 times 2 times 3 times 3. Right?
How did you get 36? I'm confused.
They want us to find the value of log base b of 36. That's what we're starting with. Yeah?
You broke it down.
And I broke it down. Because I know what log base b of 2 is and log base b of 3 is, right?
We're just supposed to multiply all those together now. Or,
Now, this becomes that. We're breaking them apart.
so we gotta
Okay, so now I have 4 numbers that are multiplied together. But what does multiply mean in log world?
add.
Add. So this is log base b of 2 plus log base b of 2 plus log base b of 3 plus log base b of 3. Got it?
Hold on.
Got it, got it?
Got it, got it.
Shine on.
Got it, got it.
Capiche?
Capiche? She does use capiche a little bit. Okay, now we know what log base b of 2 is. It is 0.36356. So this guy is 0.356 plus another 0.356. And then log base b of 3 is 0.565 and 0.565. Do you see how we can just plop those numbers in there? Because that's what those are. Okay? Do that and tell me what your number is.
What
Is it gonna be 2?
What?
Give me around 2.
It's going to be like, yeah, around 2-ish.
Wait, are we solving for B?
No. We're just trying to find what the value of that is.
Oh. 1.84.
1.842.
2.
Good. 1.842. Do you see how we did that? Now, the problem here is, like, if I'm trying to find what log base b of 36 is and just plop that into my calculator, I can't do that unless I know what the base is, right? Does that make sense? I can't just find, like, plug in log base b of 36 into my calculator and it give me 1.842 because I don't know what b is. But they tell me what log base b of 2 is and what log base b of 3 is, right? So that's why I'm breaking it down into pieces. Now, the only other thing that I could do is instead of doing log base b of 2 and log base b of 2, I have 2 times log base b of 2 plus 2 times log base b of 3 because there's 2 of them and there's 2 of them, right? Does that make sense?
Yeah.
Okay, so I could have done it that way as well. But you'll get 1.842 and that is the final answer. We're breaking 36 down in terms of 2 and 3 because that's the only ones that I know, right? Confusion?
No.
Okay. All right, last thing is something called the change of base. Okay, I'm going to give you a couple short examples over here, change of base. Ready? Let's say I have log base 2 of 9. I don't know. And you guys know how to change the log base in your calculator. Some of you guys do. But if you don't, your calculator will think in 2 different bases of logs. It will think in terms of log base 10, and your calculator will think in ln, which is log base e, right? Those are the 2 things that your calculator will think in. Your calculator doesn't automatically think in log base 2 unless you tell it to, right? So here's what I can do. I can change a log to any base that I want to, and here's how I do it. Blink and you miss it. This is really fast. Ready?
Hold on, pause.
Okay.
Okay, I'm ready.
If I'm trying to convert it to log base 10, all I do is log base 10 of 9 over log base 10 of 2. This number goes in the top. This number goes to the basement because he's already in the basement, okay? If I want to do ln's, I could do ln of 9 over ln of 2. I can change to any base that I want to by doing log of the big number over log of the basement number, right? Got it? Does that make sense?
Yep.
Now you can type this into your calculator or this into your calculator and you can get an answer for the decimal rather than changing the base. Rather than changing your calculator to base 2. Does that make sense?
Whatever
Okay.
we want to, though.
I mean, you
We
can.
get the same answer.
Yeah.
3.17.
3.17 is what you should get. Something like that is what you should get.
For log, no.
They both should be the same though.
Oh, they should?
Yeah. Yeah. Oh yeah.
For ln and log?
Yeah, because log in it.
Log of 9 divided by log of 2 is the same thing as ln of 9 divided by ln of 2. Now, here is what is not true. Are you ready for this? Okay. If you're going to type in one of these, like let's say you're typing in ln 9 divided by ln 2. Are you watching? This is not the same thing as ln of 9 over 2. That is not the same thing. Okay? And a lot of times what your calculator does is as soon as you type in ln, it will open a parenthesis. You need to close that parenthesis off before you do divided by ln of 2. Right? So be careful with your parentheses, and these 2 are not equivalent to each other. You do need an ln on the top and an ln in the bottom. Got it? Got it? Got it?
I got it.
Okay. All right, let's do this one. Estimate what 2 consecutive integers this is between. So log base 4 of 153. This is saying if I set it equal to x, this says 4 to what power gives me 153? Okay, so here's where I'm estimating in part A. I want to know what number he's going to be between. I know that 4 to the first power is 4. I know 4 to the second power is 16. I know 4 to the third power is 64. I know 4 to the fourth power is 256. So 153 is a number that's between 64 and 256. So x should be between?
3.25.
It should be between 3 and 4. So
3.6.
between 3 and 4 is what I'm looking for. That's answering the question A. Estimate what two consecutive integers it's between. It has to be a number between 3 and 4. Okay. Use the change of base formula to approximate that by using base 10. So I want to be able to type in my calculator log base 10 of 153 goes on the top. Log base 10 of 4. Now you don't have to type in the base 10 because it's already base 10, right? So it's just log 153 divided by log 4. And you get 3.63.
6.2.
What?
7.
3.6.
4 decimal places.
6. Okay, how many decimal places are we going?
4.
Oh, 4 decimal places. Oh, okay. 6 what?
287.
287? Perfect. 3.6287. Got it.
I changed
Okay.
my base, I got the same thing.
Use the change of base to go to a base E. So I want log base E of 153 over log base E of 4. Now what's log base E mean?
It's the same thing. LN.
ln. So ln of 153 divided by ln of 4, you should get 3.6287.
Check the result.
Okay. Check the result by using the related exponential form. What does that mean? So take 4 to the 3.6283 power, or 87 power, and see if you get 153. Now, if you type it in like that, you won't get 153 exactly. How's come?
Because it's not.
This number's rounded, right? Okay, so if you go to check your answer, the fact that that number is rounded to 4 decimal places won't give you 153 exactly, but it'll be awful darn close. Okay? Make sense?
Hold on, let me put it in.
Yeah. Okay, sure. What do you get?
I'm putting the whole thing in.
Oh,
I got 100.
I got 152.9999999.
Oh, I for 99999.
fudged a number.
Yeah, that's what
They're
I
just
got.
having you check your answer. So check it by plugging it back in. 4 to that power gives you 153. It won't be exactly 153. 152.99999. Perfect. Yep. That's because we rounded it. So, anywho, there you go. Questions about that? You can change to any base you want. Okay, there you go. That is all I have. All right. Goodbye, people watching this video.